Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Kong. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting webinar ahead, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded. So if you miss any of our discussion, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude this live session. If you have any questions, we want you to send those in using the Q&A tab, which can be found on the right side of the screen. And for any other comments or thoughts you have throughout today's program, we want you to use the chat tab. So feel free to interact with us there. We will have one poll here close to the beginning of our webinar, so we do ask for your participation there. And I'll also point your attention to the handout section where you'll find a couple of handy links that will help aid in today's program. Finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is understanding the new Kubernetes Gateway API versus Ingress. And joining me is Victor Gamov, developer advocate at Kong. Victor, thank you so much for being here with me. I'm going to let you take the show.
Thank you, Cody. It's great to be here again, and hopefully we'll get the awesome webinar, and hopefully many of you are learning some of the exciting things that I'm personally excited, and hopefully I will be able to share this excitement with all of you. Just before we jump in, I just want to make sure that I do see anything that I need to see in terms of, like, I probably don't see it anyways. Do you see my screen right now? Everyone should see my screen. And yeah, I think we can jump right into this presentation. All right, so if you see this few words meaning that your screen sharing is working, my screen sharing, so it's not yours. And in this presentation, we essentially will be talking about like one particular thing and how this access to your application that run inside the Kubernetes will be the way how you are dealing with this access, how you will provide external traffic and route traffic into your application from external world, how this will change with introduction of new and work in progress API called Gateway API. And today we're going to be talking about how it's different. So first of all, I'll try to introduce you to idea of Ingress and why we need Ingress in the first place. And we will switch to Gateway API. I'll show you some of the few new APIs that will be available in the Kubernetes world. So just to be on kind of like to be like very nitpicking about the word API that we're using. Here I'm using word API only in the context of APIs that are available for me as a developer in Kubernetes, meaning that my stuff that I will be using to deploy my applications will use those APIs. My name is Victor Gamov. I work as a principal developer advocate here with Kong, and I'm happy to share all the knowledge and all the excitement things that I like to talk to people about this. So essentially 3 points that we're going to be talking today. I will talk to you a little bit about how the Kubernetes networking works. We'll switch to Ingress and why we need Ingress. And the third place, we're going to start talking about Gateway API. Unfortunately, I don't see any results of the survey. If there was something that you're already using, but like we can discuss this after the fact. And I don't know, Cody, if you want to like throw some questions when they appear, or we can talk this afterwards. So for me, it works both ways. It's just about the matter of context. And if there's some questions would be related to something I showed or I said, I think it makes sense to bring this in. Okay. So in terms of stuff. I recently showed this presentation in this year Copenhagen, so that's why the hashtag is here. So, but you can also use Gateway API hashtag here. So, And the idea when you're running your applications inside Kubernetes is easy. So you have some nodes, but as a developer, you don't see those. And when you tell Kubernetes to do something, essentially just go and say, Kubernetes, I want you to deploy 3 replicas of my application, and Kubernetes will make it happen. So Kubernetes is the system where you're telling what you want to have, but you're not telling like explicitly how you can do that. The idea of having this type of system that allows the developer not to focus on the underlying, the way how the application will be balanced and the way how the application will be deployed, and you just only can define what kind of resources you want to have, and Kubernetes will make it happen for you. So it's just like automatically. In order to get access to those applications, you usually use the concept called service. Service, it's the standard networking API that creates kind of like internal load balancer, for lack of a better word, that allows you to distribute your load between your application internally. So when we're running your applications inside your Kubernetes cluster, using service, you will be able to address. So like you can use something like orders dot default dot svc the cluster dot local. That's going to be your like internal name for your service. When you want to expose this, you have a few options here. Actually, this service can be defined with special type. So by default, when you're creating this service, Kubernetes service, this type is cluster IP. With this, it will be available internally. If you want to expose this to outside world, they have two options. One is the node port. So in this case, it will follow something very similar to network address translation idea. So you will have external IP address, and you will be having some of the port. When the consumer of your API wants to hit this from outside world, it needs to use this port, and Kubernetes will route this down to your application. That's not very convenient. If you want to expose the API for every new API, you need to provide this port, which is, it's kind of like a silly in the not very 2022. So there's a third option called load balancer. With the load balancer service, you will your Kubernetes cluster will assign you external IP address. So it's up to your infrastructure configuration team if you're running Kubernetes on premise, or if it's up to your cloud provider to get you this like external IP address. So with that's kind of like, it makes sense. You need to have external access. This is how you did, this is how your father did, his father, how your grandfather did. We need to provide external access. We need to define load balancer. Now, it turns out it's expensive, not only from perspective of resources, but also perspective of money. Plus, the pool of external IP addresses is very limited. So, like, if you want to create, if you want to have a little bit more applications, say you want to create more services that you deploy in Kubernetes, so you need to provide load balancer for every service. As you can see here, the pink or salmon order service will have a salmon load balancer. Analytics will have the like violet load balancer, and the bills will have a blue. Well, it turns out not many people, the members of this community decide, okay, so that's not the way how the people should deal with it. So what about we will consolidate this? We consolidate this on the proxy side of things, right? We consolidate this on something where we can manage access to those applications in a centralized way. So, and this is how the idea of Ingress come into play. So Ingress, it is a vendor neutral specification that allows you to define different things in your how your system, like for example, Bill's system will be available through Bill's URL and things like that. But this underlying mechanism is essentially is going to be some sort of proxy sitting there anyway. But when you define an ingress object, you don't see this proxy. So you don't see this proxy, and this proxy actually can do like multiple other things for you. With Gateway API, that will change this. We will have this proxy a little bit more explicit. So with ingress, only thing that you have an ingress, and inside ingress you define an ingress class. With Gateway API, that extends ideas around ingress, we'll have a little bit more objects. We're going to talk about those in details in a second. But let's think about why. Why you need to have another new API. So first of all, your ingress was designed to serve only level 7 type of traffic. So if we look into ingress, it was designed to serve like HTTP type of traffic. Like if you go to some URL, it hits the IP address. This IP address will be representing the listener, like network listener, for this ingress class, your proxy. And again, some people don't even know what kind of proxy they're running. They're just relying on whatever ingress your cloud provider provides them. So it is not very explicit. So you cannot like pick and choose, because sometimes you don't even know what you're running there. You can use some of the other controllers. For example, like a Kong Ingress Controller does the same thing. It implements all the specifications. But if you want to do something else, say you want to deal with not only HTTP, HTTPS traffic, say you want to do something with the HTTP2 traffic and gRPC. So in this case, you cannot use ingress. You need to somehow rely on underlying implementation. And if your standard proxy supports that, you will be able to use it. Or if you're using like stuff like a TCP and UDP services, you want to expose your Kafka, you want to expose your Mongo, you want to expose your Memcache, whatever, something that will be working around on TCP, you need to either come up with some ideas around load balancer or using stuff. Of course, you can use all this service, and you can use node port, you can use load balancer, just define load balancer. But if you want to do any traffic management, it's basically you all on your own. You need to come up with something. So that's where the creators and the community come up with this idea. So we will define a new type of object called gateway class that will be representing a kind of interface that the one particular gateway will be implementing. And after that, we can create multiple gateways based on this gateway class. So this gateway class can be shared across multiple namespaces, multiple teams. So you can have your cluster operator will, and this operator should be asterisk here. And this operator can be in human operator, or it can be programmatic operator. We can talk about this in a second. And only thing as a developer you need to define is a route. So this route would be attached to a particular gateway, and this route will be will move the traffic from gateway to your service. So let's take a look on the some of the things what possible to do with this. That's where we have a separation of the roles. We can share gateway between different teams. So we have a cluster operator that created a gateway. It already configured certificates, so applied some of the default RBAC policies and things like that. And you have two developers. One developer has a application with store that will be available /store, and there would be a developer that will be using same gateway, but it will define another route called HTTP route. And with this HTTP route and HTTP and the site routes, you will be able to do different things. For example, the store developer will be able to do kind of like canary type of deployment, or like a traffic split, some of the or maybe A/B testing. Some of the 10% of the service of the traffic will go to one service, and another one will go to another. So that's basically the idea, but the more things will get much more clear, where I will go to demo. This is where I would like us to start doing things. All right. Okay, cool. So I have a Kubernetes cluster up and running. I already have something that's installed there. So first of all, I will start with the Kong Ingress Controller. And I install Kong Ingress Controller using Helm chart. So if I'll do something like Helm install, and I'll just do this one. This is how I usually install Kong using Helm. And if I'll do ls, so in all namespaces and Kong, we'll see that Kong is up and running. Interesting thing here that I need to, in order to this thing to work, I need to enable these secret features. Not that secret, but we call it feature gates. And we need to tell that Ingress controller needs to start and in a form of a gateway true. So the way how it looks like, so if I go into my Kubernetes cluster, and if my internet is still struggling. If I go to Kong, and I will see this my Kong Ingress controller, and inside my Kong Ingress, if I do something like gateway, so I see that when I run this, configuration was found for gated feature. So let's do, okay, and I will just do this one, and I'll just do gate. And in this case, it will start this Kong Ingress Controller with support of this. Now, I mentioned a couple things that this Gateway API introduces 2 or 3 or 4 few new APIs. One of these new API would be called a gateway class that allows me to define my Kong as a gateway provider. In the concept of gateway API, this thing, the gateway class will be something that the infrastructure provider will define. So this is something like system administrator will configure, and after that we define this class. So in this case, if I go in my Kubernetes cluster and I say, not this one, I will just go namespace, and I'll go in Kong namespace, and after that I'll show gateway class. So it says like there's one gateway class right now for Kong Ingress Controller. Now, so the next thing that I will define a gateway itself. So gateway will, the object that I will be reference and link with my routes. So the request will comes into this application. This request will be served by this request will be served by this gateway, and after that, this gateway, with certain rules, it will route this traffic into Kubernetes cluster. So if I will do something like, let me do this one. So first of all, why I did this? So we need to access this somehow. And in order to access this somehow, I need to go to services and define that this one service with load balancer. So this is the external IP address. So like everyone right now, if you have any tools that curl or Insomnia, for example, we can hit this, and I will go ahead, say new request, my request, just do Kong, and I create. So I can go ahead and just copy this guy and hit this URL. So this is the traditional response that I'm getting from Kong, means that the Kong is up and running. There's nothing is configured, so I see that Kong is working. Also, I configured my server will be available on DNS name. So if I'll just do something like dig short Kong, I will be able to hit this. So this is our guy. So we're going to be doing with this. Just do Kong proxy me. Yep, it works. Still works. So far so good. Now, so next thing is that since I already configured these two guys, I need to next have some sort of deployment. And if I can say in my namespace default, I'll have two services. One service will be responsible for providing me with back to future quotes. Another service will be responsible for providing me with Chuck Norris quotes. So those deployments are pretty simple. There's nothing really special about this. There's a one image that, again, you can grab it and use it yourself. If you provide different environment variable, it will start either back to future or Chuck Norris facts service. So with today routing examples, I will try to configure access to both the services. Now, remember those services in our default namespace, all good. So next thing, that how we can configure some sort of, the access to this one. We're going to start with first the very basic example. We're going to be using HTTP route. This is another new type of API that comes as a part of the gateway API. So you learn about gateway class, you learn about gateway, and now it's a HTTP route. The way how we can link those together, map those together, is by defining this parent reference. I will bring this slide real quick so you have an idea what are we talking about. Slide with this relationship again. So this is what we defined as a class. We use a Kong as implementation of this gateway. Now we're defining this HTTP route. And this HTTP route will be mapped, you see this many-to-many, mapped to a gateway, and we will see how this will help us. So I'm go ahead and just do apply. So what it says, if I will hit, say, this server, no routes, but if I add header, say host, and that's going to be back to future Kong proxy me. And now, what we see here, it's the response that came from back to future service. As you can see here, my application adds some extra headers that reports back where this response came from. So in this particular case, this response came from back to future quote service that is backed by, this is my service, and this service backed by this deployment. So if I go here, and this is my back to future service. Now, with this, if I will go and just do, say, let's see what kind of HTTP routes we have. So that's HTTP route we created. Let me describe. HTTP route connected to Kong, and it will, this is the part of specification. That's the parent reference. So which gateway will be serving traffic from this particular thing. And we're not going to use any path prefixes here. It's going to be our next example. So next example is using path. So now, if I will hit this particular URL, I will be, let me put this here. But now if I will just do back to future, I'll get the 404 from Kong. So there's, nothing is there. So what I will do is go ahead and just do apply. and now we see here in my HTTP routes, there's another HTTP routes that will be using path. So if I will go ahead here and do this, let me remove the header, because in this case it will be interpret and path and header with this, and I don't have a rule for that. So now you can see here, I'm still getting the response from this back to future. My response still goes through the Kong, and I have some payload is my output here. Now, next thing is that we want to do something a little bit more interesting. So in this particular case, we're going to be using the header-based routing. So we're going to be using a header to define what kind of service we want to hit. So in this particular case, if I hit this conproxy.me service with particular header, in this case, it's going to be arbitrary header. In this case, I will be using quote header with the roundhouse kick value. In this case, the traffic will go to Chuck Norris quote service. So let's try to do this. And in this case, I will go ahead and just do apply. And let's get back. We see my new route, Chuck header here. So if I'll just do quote and here, removing this guy. And now I have a response from Chuck Norris service. And as you can see, my routing was successfully configured here. So that's what it gives you. So you can do different sorts of routes, and more importantly, the similar way you can configure like the same communication to your services. Now, important thing to note that if you want to see, if you want to play around this with yourself, so you can go to this. That's my repository called demo scene, and you can find Kick Gateway API with a brief explanation what you need to do and how you can do this. That's very simple. I'll do a quick pause before we jump to another part, which is it's exciting. It was not advertised, and for those of you who stuck around for a while, you will hopefully you will enjoy this. Okay, so let me see some of the questions. Can it be used in the multi-cluster deployment? So that's rather very complex questions. So technically, nothing prevents you from using this in the multi-cluster environment. However, like how you will be deploying multi-cluster, and this is where we're gonna be talking something like this in a quick second. Usually bringing stuff like a service mesh that allows you to do like a multi-cluster communication, and some of the things that were recently announced in the service mesh world. Is gateway class and gateway are cluster scoped resources or namespace scoped? So essentially, let me bring this slide. So you defined the classes and gateways based on the cluster, and more importantly, that's the cluster operator role to define this for you. So as an infrastructure provider like Kong, we can provide you with the gateway class and gateway implementation, it's a responsibility of cluster administrator and the infrastructure provider to configure this. Now, they can be accessed. You can define a shared gateway that can be shared between multiple routes that deployed in different namespaces. So that's why you can see here, there's a store namespace, and there is a, see, this is the store namespace, and this is the site namespace. Those are different namespaces, but they can share same gateway that defined for them. They can bound these resources to this gateway, and this gateway can be shared. So I hope I answered this question, Anu. What's missing in Gateway API today that exists in Ingress Controller? So it's a very good question. Anonymous attendee, anonymous name, attendee is the last name. So essentially nothing much. So right now the problem with Gateway API and wider adoption is still right now in alpha. If you go and see this, so all the API versions. Let me remove this zoom table. You see here, it is right now in alpha 2. So it is not something that's like very stable. Another problem is that these CRDs, let me bring this real quick. So if I'll just do a gateway API CRDs. Where is it? GitHub. I'll go to GitHub and config CRDs. So those CRDs that currently stable right now, they're not as a part of your cluster. So you need to install CRDs first. After that, you need to bring a gateway implementation that is somehow you can find in this website. You can see there's the implementations. There's actually quite a few of open source projects and community members who are working on this. Right now. So, like in a technical sense, if we will comparing the ingress and gateway, gateway already has quite the features that allows you to use this like much easier than ingress. For example, the header-based, header-based routing, which is something that you can do, but with particular implementation. Like you can do this with Kong, if Kong is your ingress controller, but there's nothing in ingress that allows you to do that. You're extending the basic functionality of ingress, and instead of instantiating header routing plugin, how I can do that with new kind of Kubernetes? Now I can do this with new kind of Kubernetes. Is that right? Yeah, that's correct. So previously, extension of ingress happened based on certain functionality that vendor will provide you. Again, Nginx, Kong, and stuff like that. And you need to have external plugins to do this configuration. With the with Gateway API, you not doing this anymore, so it's going to be part of the standard. How I can use Gateway API if I have a multiple Kong gateway running in the same cluster? Is Kik have much namespace and filter in ingress? Very good question. I promise you it was not seeded. Very good question, Anup. Thanks so much for asking this. Here's another interesting thing that will set up answer to this question. So you can find this very interesting thing when we define a gateway. There is a special annotation says gateway unmanaged, true or false. Right now, this particular object expects you to have a Kong deployed. But wouldn't it be cool if you can spin up the actual gateway, actual proxy on demand based on your particular request? So you define, your cluster administrator define you a role in your, not a role, the gateway class. And after that, you can, as you need, you can spin up multiple different proxies for particular different use cases. So that's where the gateway unmanaged false will come into play, where there's something that we're working right now. It's right now in the POC state, and if you're interested in this type of JS, I recommend you to follow development in Kong Ingress Controller repository. So there's a POC state that allows to kind of like spin up the gateways as you please. This is something that we're working on, a gateway operator that allows to start different instances with different, maybe even different configs for this particular use case. So answer to your question, so you can run multiple gateways within one cluster, and multiple gateways with the different gateway semantics. Now, I want to show you something cool before we go. Just the last one is very quick. Does Gateway API support MTLS? Well, it does support TLS. You can expose you can provide HTTPS for HTTP route. It's there. But MTLS between gateway and your service, I think it's a part of implementation details. So Kong does support this. You can do this with Kong, like MTLS between Kong and underlying service. You can do that. Okay, now, as I already said, and if I didn't mention this more explicit, Gateway API, it's a standard for API, so meaning that similar functionality will be available on the different providers. And there's something that we're working on say, another side of the Kong here. So how many of you actually know that we are working on service mesh, which is Kuma? It's open source CNCF project that give me a second. I'll bring the example of this. That's something that we're working on. It's a CNCF project that's called the Kuma, and in Kuma, as a service mesh was designed to running your application inside your data center and providing this intra-application connectivity features. However, Kuma was supporting Kong for a while as an external gateway. Sometimes many users, they don't want or don't need to use Kong, or they want to use like some simple features like routing that I just showed you without doing anything like super fancy, like enabling some plugins, or even this example with this MTLS, like the Kuma allows to do MTLS super quickly. And if gateway would be part of the service mesh, you can enable this very quickly. So now the Kuma also supports Kubernetes gateway API. So let me quickly spin up a Kuma. You can find example for Kuma as well so I will be doing this. Okay. In my demo scene, I need to go to Kuma Gateway API, and I'll just do Helm Kuma. Kuma also has a feature flag that disable this by default. Now we will enable, and we'll see how we can do the same stuff with different implementation. That's kind of like one more thing that I wanted to show you. So it will grab the Helm chart for Kuma, and it will spin up a, let's see. I'll go to namespace called Kuma system. And I will just do port forwarding to bring some of the Kuma UI. So next thing, I need to deploy my applications. So the applications will be part of my thing. So in this case, I need to create a namespace that allows me to do injection of. Okay, so let's see if it's still a thing. If I'll just go to namespace and I'll just do a Kuma demo. Okay, and I'll just do describe. And it still allows me to inject a sidecar container. So like inside this namespace, I will deploy my applications, and my applications will become part of this service mesh. So what I will do here, and I'll just do and 02 deployment, and we'll do this deployment folder. Okay. Kubernetes. So I will deploy these two applications now inside here, and I will see this little quick in here. Fresh. Okay, so now I have two services that runs inside my application. One service is a Back to Future service, and another one Chuck Norris service. Now, so this is how you can, run this stuff in your service mesh, and now you can enable like MTLS between the services and all these things like super cool, super fast. But now what I wanted to do is to provide a gateway, as right now there's no gateway data plane proxies that will allow me to get access to this application. So for this, I need to do is to create a gateway for Kuma. Now, as you can see here, I also define a gateway class, but in this case, it's going to be a gateway Kuma.io/controller. If I will compare this, let's do this comparison. So you will get compare files. Yeah, so you can see they are very much alike. You're going to be using the same thing. The difference is I prefer API versions should go up. API version should go up. So this is going to be using name Kong, and it's going to be named Kuma. In this case, API version also go up. Gateway annotations. It's not using any annotations here, and in this particular case, it's going to be named Kuma. We'll put this here for namespace Kuma demo, and now it also will create a gateway for Kuma. So let's do this. So I will go ahead and I'll just I need to apply this in particular namespace. No, it should work. It should work like this. So I'll just go ahead, apply. So now, if I go in here in KNIS, just go to all namespaces, and now I will do gateway class. And now I have two gateway classes. As a provider of this thing, I have it here. I have a Kong is running here. Also, let me see service. So there's a couple things. Kong runs load balancer, and it is available in this host. And the Kuma runs a load balancer that's available in this particular host. So we're gonna be hitting this one. Give me a quick second. I will update my DNS so we can access to this host in a more fancy way. I prefer this. Instead of doing something like, dealing with IP addresses. Now, so if I will do dig short Kong mesh 82, let's see if it's a correct IP address, 82. Okay, so I should be able to get this. And when I do this one, just do HTTP Kong mesh. And I will just do Kong mesh and port 8080. So there's nothing here, but gateway is up and running. As you can see, his response came in from the gateway. Now, so what I will do here, I'm not going to do this one by one. I will just go ahead and show you the same thing that we did here. For example, for Kuma, where's the Kuma? For header-based routing, I will just go ahead and apply this with kube control apply. Should I do HTTP route name? Just do namespace Kuma demo. So in this case, if I will hit Kong me.sh with this particular header, I should be able to get access to my check notice. So we'll go here, quote, roundhouse kick. And now, so what do we see here? The response came from Kuma gateway. I see that it actually comes from the service that is check notice, and it bound to my Kuma demo namespace. And obviously response we have. And the cool thing is that I also see this in my UI, because this gateway is also part of service mesh. It's part of the Kuma. So you can see here there's data plane proxies. One is the standard. That's my application that runs inside here, and my gateway. So now you can have this as a part of your service mesh as well. So let's see if the host also works here with here. We'll just do namespace, yes, correctly. Namespace here. And when I will go ahead and update this route, when I will go ahead here and say host back to future at Kong mesh, and response waits is nothing to do with it. Okay, Marty. Okay, and response from the Kuma demo and the comes from this the Back to Future service. All right, so that's it for now. So let's see if there's any other questions. Now, what you just saw is that inside one cluster, I have two gateways. One gateway based on Kong, another one based on Kuma. With Kong, you can have all things that are available in Kong. With Kuma, you can have automatic integration with the service mesh. You can use Kong as gateway for your Kuma, and but you cannot use. So you can use Kong as gateway for Kuma. You can use gateway for Kuma using gateway API. So there's plenty of things that you can do. So there's like a variety of the things, just all you can. Is there a difference between a Kong Kubernetes Gateway API and the Kong Gateway API? It would be nice to use KTS for provisioning data plane, but still have a control plane to manage fine-grained control and the plugins. So I think there's some of the confusion in the naming here. So I'm not quite understand the question. Kong Kubernetes Gateway API and Kong Gateway API. So, okay, so probably the question is, can I use Gateway API, Kubernetes Gateway API, but also using some of the Kong functionality like plugins? So as far as I can tell, I don't have examples right now, but as far as I can tell, it's also will be working the same way. You can define with any, for example, if I go in my Kong plugin, so I don't have any like CRDs. So you still can apply all these Kong CRDs, like for example the cluster plugin, Kong plugins, and TCP ingress, and all these kind of things. You will be able to apply, and same way you should put the annotation inside your gateway or rather HTTP route. So if you go to kick and say here. So you will be able to put somewhere kind of like annotation same way as you do like a Kong hq.com/plugins and just do your rate limiting. Yeah, this type of stuff. So you should be able to do this as well. But some of the functionality that available in the Kong extending functionality needs to be handled explicitly using either Kong plugin and TCP ingress and all this kind of stuff. Yeah, but Kong-based TCP ingress and UDP ingress, all these things will be eventually available as a part of Gateway API. All right, I just have like two more slides that I want to people pay attention. We have a still good presence, right? From perspective of like 80 people joined, 61 people stick around. I appreciate that. That was great. I also appreciate if we will go to this nice link called youtube.com/Kong Inc. This is the YouTube channel that I creating a lot of content recently. There is a lot of work around the tutorials for Kong Ingress Controller, using Helm, without Helm, just like doing the things from scratch, different tutorials for different tools. Just go there, click subscribe, enable notification. You'll see some of the live streams that we do. We have an Insomnia team doing like a weekly live streams that they can break down the process, how they develop Insomnia in open source. So I would really appreciate if you would go there. Plus, very soon this page will be live for the Kong Summit. Join our community. We have a great community forum. Ask your questions in Stack Overflow. Most importantly, I don't know why I didn't mention this in the very beginning. Follow me on Twitter. Follow me on Twitter. My Twitter was conveniently placed on every slide here. So just go follow me on Twitter. DM me if you have any questions, and go follow for all announcements and the Kong Inc. in Twitter as well. And with this, Cody is back to you.
Thank you so much, Victor, for putting together this demo and for joining us today. We really appreciate you jumping on and sharing your expertise. I'd like to remind today's audience that the session was recorded. So following this webinar, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. So we do have 4 winners of our $25 Amazon gift card drawing. Our first winner is Druvit P. Our second winner is Aditya P. Our third winner is Yuan Z, and our fourth and final winner is James C. So to the 4 of you, congratulations. Keep an eye on your inbox to claim that gift card, and if you don't receive an email, just check your spam folder. I'd like to thank Kong for sponsoring today's webinar, and I'd also like to thank you, our audience, for being here with us for the entirety of today's program. Please just take one extra moment to fill out our brief post-webinar survey that should pop up on the screen here in just a moment. But otherwise, we do hope to see you at an upcoming Techstrong Learning webinar or workshop. Thank you so much, everybody. And Victor, thank you so much one more time.
Yes, thank you, Cody, for organizing this, and thank you for DevOps.com for the opportunity to speak.